Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 294, Sum of the Total Strengths of Wizards. I like how they just kind of add in the word wizard and add one line context, but otherwise it's just get the smallest number. It's just this formula, right? I appreciate them for at least trying a little bit. Maybe, I don't know. The other first thing that I want to add is the mod song. I saw the mod, I go mod, and then I type out the mod so I don't forget, right? So hit the like button, hit the subscribe button, join me on Discord because I needed wizards to help me on this problem. Full disclosure, I did not get it during the contest. Even though I got the first 3 problems really fast, I think I just struggled a little bit with I think I thought I was trying to figure out. So please give me some love by hitting the like button and the subscribe button, and leave a comment about how hard this problem was, maybe for you, or maybe how easy it is if you're solving that. But for me, and you can kind of see by the video length. Let me go over that for a little bit, just to be clear. I spent like 2.5 hours to understand this problem, and you could see that I do it during this problem. You probably don't need to watch all of it, but at the end, maybe the last like 10-20 minutes, if you're interested, you can see Larry's thought process. I'm Larry. I don't know why I said it like that, but you can see my not just me solving it per se, but me understanding someone else's solution, how to read code, how to kind of break it down, how to work backwards from that, and figure out a visualization that I can figure out how to solve it, right? That said, I'm not gonna lie, this is my first attempt in a long time in this thing. I don't know if I am able to solve this. I'm not sure that I'm able to use the technique to solve it immediate if I see it again, right? Maybe if I saw it like tomorrow, then But like if you give me like a month, I may have forgotten and stuff like that. But part of that learning is about repetition and playing around with it, right? And the biggest part I think for this problem is the visualization. That's if you have one takeaway from this video of learning and working on it, is going to be the visualization. And this part, I admittedly, I did not do a good job on. I think for me, I was focused on the algorithm, and I didn't work on the visualization. And the visualization would have allowed me to figure out the formula. I was playing around with some formulas that I was trying to figure out how to get the correct answer, but I didn't have a good approach to it. And this is me just analyzing what I did wrong, and hopefully in that way try to put emphasis on how to learn to solve this, or not necessarily solve this. I mean, obviously solving this is good, but also solve similar problems in a similar technique in the future. And for me, that technique is not necessarily the implementations that we have here with the formulas or whatever, but it's about the visualization, and which is why I said the word visualization like 10 times, right? And just a little bit of a spoiler, there is going to be some prefix sum and stuff like that, but that part isn't even that important per se. I mean, it is important. Obviously, you still need to know the building blocks and understanding that. So if you are weaker on the prefix sum, definitely play around with that. But even as someone who maybe should be good at prefix sum, I struggle with this one, right? So, but you still need to know as a basic thing to kind of like a prerequisite, right? Okay. So what do I mean by visualization? So I'm gonna So I expect that you read this problem and you understand what it's asking, right? Because I think understanding what it's asking is not that bad. And I think there is there are 2 problems that I want you to maybe work on. I'm gonna use let's see. And then actually, I would say I wouldn't necessarily say that these are, wait, what? Sorry, let me find this for a second. Yeah, and then now, yeah, okay. Let me now. I mean, I don't know. There probably is on Leetcode, but oops, that's weird. These two problems are probably on Leetcode, but I'm gonna focus on. Well, I just have this ready, so yeah. So the two problems, and oh, maybe don't look at that actually. You could look at it here on top, the URL, or you could Google for it, right? But basically, the two problems I would recommend at least getting understanding of is every sublist min sum, meaning that, and this is what it sounds like. Every problem return the sum of min x on every sublist. So basically half of the problem, kind of, if you want to call it that, but not really, right? It's less than half, but solving this problem will allow you to at least understand what you're trying to do in half of it. And then the other part of it is sublist sum, right? Which is, okay, given an integer nums, we turn the sum of every contiguous sublist. So solving those two problems, and they're probably Leetcode version, so if you know the Leetcode version, please leave it in the comments and I'll link it or something. But yeah, but let's say you have this problem is about getting the min and then multiplying by the total, right? So I think one thing that I messed up here on this problem, and this is me, self-retrospective as well, is that I kind of focused too hard on the algorithm and not the visualization. Again, is that word again, visualization, and this is what I mean, right? So I'm going to look at this code that I wrote, and it's correct because I submitted and it's correct, and then we'll go over what I'm doing here, right? So basically, I have and this assumes that you solve the sum of the min of the sublist, which we just had up above. Maybe I'll put it back up. Hang on. Yeah. So I assume that you solved this. If you haven't, please take a look at this problem and take a good try at it. And there should be a Leetcode version anyway. But yeah. So I'm gonna. And hopefully I have an explanation about it. But if you get this part, then I'm just going to go over this part of the code really, really quickly. But, so bear with me. If you don't understand this part, my apologies. But the idea here, I'm not going to go over it in depth because I think we have enough in this video to go over without me, breaking it every portion down. My apologies for that. But basically the idea about this chunk of the code is that we're using a stack and a monostack. More specifically, we basically go, okay, for every number, what is the range in which this is the minimum, right? And what I mean by here, and you can think about it as a black box, I guess, but what I mean is that, given an example, let's say here, well, let's say one will have, it's the minimum number in all these numbers, say 3, and there's a tie-breaking thing which we'll talk about in a second. 3, it's only the min in one segment, and then the 1, it's a min number in all this suffix, right? So we on tie-break we go to the right, so yeah, and then the 2 we also, it's by itself, and from this basically we're able to get the answer, kind of. It's not going to be fast enough, but we'll go over this in a second. Because now, using that other problem that we kind of talked about, or sublist sum, we have this idea of, and let's actually comment this out for a second. Right. So basically here is the second portion of it, this portion, which is that we're trying to figure out the contribution of each number, right? And then for each number to the left, we go, okay, we just add it to the numbers to the left. We count the number of ways it is possible and so forth. And this is how we get that contribution. Of course, and just to kind of really briefly go over it, let's say, we have this number again, or this input. we have 1, 3, 1, 2. So let's say we're looking at the number 1. Well, this number will be part of, this number has 2 degrees of freedom, right? Because that counts this part, because let's say for this number 1 in the middle, how many times does this, oh, actually, I lied, because as we said, we only count to the left as a tiebreaker, so this only goes to here. So then now we have 3, 1, and 2. And then we've count, okay, how many times does 3 appear, right? Well, 3 appears in 2 possible sequences, which is 3, 1 and 3, 1, 2, because it has to include 1. So yeah, so it has 2. Okay. So then to the right of the 1, we have 2 degrees of freedom, because we have 1 number, so we have 2 degrees of freedom, right? And to the left of the number 3, we have no number, so that is 1 degree of freedom, meaning we can choose. Let's pick another sequence really quickly, because I think this is kind of a terrible example now that I think about it. Allergies induced things, but yeah, let's say we have this number, right? And now we're looking at I is equal to 3. Well, how many times does 3, and this is contribution, you try to figure out by contribution, right? How many times does the number 3 appear in this answer where 1 is the min, right? So we have 1 is the min. How many times does the number 3 appear? Well, on the left side, we have 2 numbers, meaning that we can go 3. Let's just ignore the left. Sorry. Let's just ignore the right for now. We'll just use a segment. But now the prefix could be this and then this, right? So now we have 3 degrees of freedom, as you can see, for 2 numbers to the left of the 3, right? So that basically explains this part. And then the right side is just ignoring the left side. You have 3, 1, and then we try to figure out how many numbers are on the right. So because there are 2 numbers, there are 3 degrees of freedom, right? Which is the same idea here. You have 1, 2, and then you can extend it twice, right? So that's basically the idea behind these 2 formulas, and this is just the formula that's about the number in the middle, and then you multiply the left and multiply the other way, right? So this will. So take a second or two to understand what this formula is. I mean, of course, this is going to be too slow, but that's basically the idea. Yeah. So that's basically going to be the idea. Okay. And then now, the idea here is to figure out how to optimize this to something that, because this is excuse me, in the worst case this is going to be linear time, and this is linear, and given that n is 10 to the 5th, this is going to be too slow, right? So I knew this, and I had this during the contest, but but I wasn't able to make the right visualization because I was trying to figure out a lot of different techniques so I could kind of do it in a cleaner way, like using sliding windows, using sweep line algorithm type things. Some of these ideas you could see me attempt later. Some of them probably should work, but it's very hard to get right, at least for me, right? And then this is where the idea of prefix sum and double prefix sum or pre-prefix sum comes into play. So then here, let's go over a little bit what prefix sum is, right? So let's say, we have A1, A2, A3, A4, dot, dot, dot. So then the prefix sum is just 0, A1, A1 plus A2, A1 plus A2 plus A3, right? dot dot dot. So basically what we're trying to do here, what my idea is, okay, so that's prefix sum. What in terms of contribution, another thing is, which is why I talk about these two problems, is that you have to figure out how to figure out the contribution of each number, right? Okay. So let's just say, for example, in a very naive way, the segment that we care about is this one, and let's say the min is a of v2, right? So that's the min. So then now, let us figure out what the contribution is by enumerating all the possibilities, right? So we have one number to the left and three numbers to the right. So then here, there's going to be 2 times 2 to the left, 4 to the right, 8 number possibilities. So for visualization, I am going to write that out, even though it is a little bit exhausting, but that's okay. I'm doing for the fans at home, so come with me here. Yeah, so this is A3. Oh, this is plus, right? Excuse me. And of course, the reason why I write it like this is because if you write it like this, you'll know that addition is distributive, commutative, all these other good stuff, and therefore that's where the how we figure out the contribution, right? It's because now we're just trying to count how many times things appeared. Man, sorry, friends. Yeah. So basically, that's the idea, right? And here, when we talk about contribution, is we try to figure out, okay, is there a way we can count A1 or A2 or A3, independently, so that we can kind of at the very end just sum it together in a different combination, right? Like, because we do it with this way, it's similar to the way that we do it here, but if we just do it like one at a time, it's gonna be too slow, right? Actually, let me actually change it a little bit. Let me go to A3 because I think this, or actually, let me go to A4 because I think this is actually a little bit clearer. And you'll see why in a little bit, but I think this is a slightly different visualization. But I think this will be easier to understand, maybe, or easier to kind of visualize. So A4. All right, let me just actually write out this thing and then just. Sorry, friends, give me a second. Yeah. So then we have, A4. Right. And then you have A4 times plus A5, right? So that's on the right side. Maybe. Yeah, maybe I should. Give me a second. Ask you all this hard. Okay. And then now, again, but with A5, right? So this is the same as we had before, kind of, but, just the left, right. And the reason why I like to do it, changed it up a little bit, is because now you see that there's 8 ways of doing it. Okay. And then now, our idea is using prefix sum of prefix sum. So as we talked about, maybe another way is that I'll write this vertically. You can kind of see here, right? Maybe it's worth writing it out. Well, right? So this is prefix sum, right? So then the idea about trying to do it in all of one time is try to squish these things in a good way. And then the idea is going to be and there are a couple of formula, like I'm not focused on a formula to be honest, but I'm just trying to figure out, because once you get the visualization, which is what I'm trying to do here, the formula will come in. There are a couple of formulas you can do from this, and there are a lot of techniques that people have done on the contest, but all of them stems from the same idea of this visualization. And I would also say that if you have a lot of practice, if you're very good, then sometimes you get to jump ahead very quickly on the visualization and solve it very quickly, like some of these very good people. But keeping in mind that they've done these kind of problems for years and years and years and practice and very smart and stuff like that. So, you know, just to kind of give you, you know, that idea, right? But if you want to solve it by yourself, this is what you would need to do. And maybe some of it is I'm talking to myself because I didn't get this correctly. This is what you need to do it, right? And then here, the idea is kind of tricky to get right, to be honest. The idea here is, okay, so how do we use this, right? Well, another way to write it is, and maybe that I kind of threw you off a little bit. Let's actually reorganize these a little bit, and we can do it here. Right? So then now, oops. Right now we have, you know, that, right? And so, let's say for a second, now that we organized it like this, we want to get the sum of one of these components, right? So what does that mean? That means that we're trying to get A4 plus A4 plus A5, right? And of course, and from this notion, we're trying to use the prefix sum, right? Yeah. Or the prefix of the prefix sum. Because if you think about it, right? That's basically what you're doing. And now it's just about formula manipulations from that. Let's actually write out what it means for the prefix sum, prefix of the prefix sum, right? So you have 0, you have A1, you have A1 plus A2, right? You have all these things, and then now the next one is this, but with slightly different thingies, right? Yeah, and I need one more for 5. Okay, fine. So that's prefix sum, right? Oh, this is the prefix of the prefix sum, right? So then in order to get this, we just have to basically take this number minus excuse me, minus this number, right? And then what do we get? If we take this number and minus this number, then you would get, well, not this, right? You would get these two. And this part is a little bit tricky. Like I said, I hope that you really understand prefix sum before getting here, because otherwise, I have some additional visualization to kind of explain this part. But that's like more fundamental prefix sum stuff. So that's why I'm not, you know, doing it, right? And then here now, now you can see that we have this, and we're trying to get from here to here. And so And yeah, and this is just for this particular piece, right? There are a couple of ways you can go from here now, actually, which is why I'm hesitated for a second. And depending on your visualization, you're going to have different formulas, right? So I'm going to go over both of these really quickly, but I trust that you're at home, you're smart, and that you can figure out the actual formula. But yeah, but basically, I misspoke a little bit. You're not trying to get from here to here per se. You're trying to get from here, right? Let me erase this for a second. You're trying to get from here to here, right? And there are at least two ways of doing it. One is by multiplying this, let's see, 4 times by the number of, and like from here, I trust that you're at home, you can implement this. But let's say we multiply this 4 times, right? So now we have this. Well, obviously this is not quite yet right. But now we're trying to remove two things, right? One is, well, not two things, just one thing, depending on how you want to do it. But you're trying to remove this chunk. Pretend this is a rectangle. I can't really draw it that well. But this chunk minus this chunk minus this chunk, right? So you can think of, so you have all this stuff, and this is all added up. So the comma is weird. And this is what I mean by visualization, right? So like, let's say now you have this, and you're trying to remove, well, A1 plus A2 plus A3. So you're trying to remove this twice, plus trying to remove this, and you're trying to remove this, right? So this plus this equals this. And of course, the other thing you will notice here is that, well, what is this stuff? Rewriting this or rethinking about it in just visualization, you can think about it as A1 plus A2, just like writing it upside down, really, plus A1 plus A2 plus A3. And that's pretty much it, right? Obviously, this is times 2 because we have A5, which is 2 degrees of freedom. But this is basically it. And if you... Sorry, friends. Allergies are still kicking my butt. But yeah, I mean, I think at this point you realize that this is just this. From the prefix sum, the second order prefix sum. So here now, you have all the components to calculate this number, right? It's just basically here minus this, and that's basically the way that I did it. Another way that you can do it is, sorry, friends. The other way that you could do it is that going from here, another way that you can do it is that going from here, you notice that here we can just get rid of all these, pretend this is a rectangle. So this is just this, right? Let's say there's 8 of them. So now you have this number in terms of visualization minus this number, and this will give you, well, it'll give you now this times 8, right? Or times 4, I guess, with 8 of these in total. Because this number is just this number minus this number, right? And now that you have this number, well, now you have to add back what you have to add back to get to here, right? So now, same idea, really. But you have A3. I mean, I could. I think I deleted it, but same idea, right? I think you get the idea at this point, which is that now you're trying to add these things back in. And yeah, they line up. So then now you have this number minus or add this number to get this number, right? So basically here you can think about it as you're getting this number minus this number plus this number, right? Let me now just delete this for clarity. So basically you have, yeah, minus and then add this back in, right? So that's basically the idea. Again, you know, you could this number is just actually so this is a not even a second order prefix sum. This is just a regular prefix sum. So you could calculate this pretty straightforwardly. And here it's again, it's just this number times did I? Yeah, it's just this number times 3, right? And of course you can play around with how many times these repeat and stuff like that, but that's the visualization to get the problem, to get the solution, which I definitely was a little bit weak about. And if I drew it out, then this would have gotten it, I think. But yeah, we spent half an hour just going over this visualization. So hopefully, this made sense. I'm going to delete this part really quickly so we could look at the code together and talk about what I did. But that's basically the idea. Hopefully this is a good visualization for those of you at home. Yeah, so basically here it gets to the left index and right index, like I said, to get the span. And then now I keep track of the prefix sum and the second order prefix sum. I have this for loop, which kind of what we're talking about, but instead I have this other formula that basically is just what we talked about earlier with the first method. And if you understand this, then this code is just like just making sure you match the index and thinking about it carefully and stuff like that. And then you just multiply it by the min number, which is the current index, and then at the very end, that's pretty much it. Ignore the print statements, and that's pretty much it. As you can see, this is all linear time. This is all linear time, so this is going to be a linear time algorithm and a linear space algorithm, just because we keep track of the left-right prefix and the second order prefix sum. Yeah. That's all I have for this one, really. Let me also show the top of the code real quick. Hold for a second, and then show the bottom of the code so you can kind of type it out and play around with it. Also, if you come to my Discord, I have it. I have it so that you can copy and paste. But I think one thing that I just want to point out is that like I. No one taught me this per se, like this solution for this particular problem. What happened here is, I kind of worked backwards from the solution a little bit, to be honest, but I try to figure out the visualization that helped me solve this one. If you're curious about, how not just the learning, you're curious about not just how to or the learning portion of learning the techniques, but how I convince myself to learn this. Watch the end of the video. I mean, skip ahead a little bit or keep jumping ahead if you like. But I think like maybe it's informative, maybe it's instructive in trying to look at like, okay, how what pieces was I missing? How did I figure it out from scratch and so forth? So yeah, let me know what you think. And you could watch me attempt to learn this problem live next. That was a little slow, to be honest, but Mod. Though I think this one's maybe obvious anyway. Okay. I feel like I've done this problem. I feel like this is a binary search problem, but it's annoying because I feel like someone gets this in like 2 minutes, but I'm blanking out. I mean, I know how to do it, but let's see. Maybe I don't. All contiguous. Okay. Let's see. And it's big. Okay, so this is just how far it extends, and then we'll just do the math later. Maybe. Okay. I might want like this bit. Okay. I do that nums? Oh. For some reason I do nums. Okay. so 1 is -1, 1 is -1, 2 is... Okay, so basically, yeah. This one goes to 0, 1, 2, okay, that's good. This number goes to the smallest is by itself. Wait, yeah, 2. Yeah, okay. Let's see, am I interpreting it right? Okay, so basically for 0 it goes one number to the left and then 2 numbers to the right. Is that right? Am I getting that right? I'm saying total there are 2 sequences. Is that right? But this is the main number. What about this one? 1 is 2 numbers where this is the main number. Am I getting this right? I feel like I'm uncertain about the off by 1 aspect. No, that's not true. This is left right. So this 1 goes 1, 2, 3 because this has the contribution. Okay, that's why we have to think. Okay. And then now we have to do People already finished probably, right? Yeah, no, huh, that's actually surprising. Okay. And so that's the number. And now we figure out, okay, so that's the contribution of itself as the main number. And now to figure out how to do all the possible subsets, right, of between 2 indices, which in this case would be how do you do it? You have to do it again with respect to this one gets them in, and that's okay. But then now we have to do, for example, this 2. We have 3 numbers to the left, including itself, and 2 numbers to the right, including itself. So then now the left indices let's see. So 1, 2, so -1 to 4. So that's exclusive. So that's 0 to 3. Alright, so that would get the answer from 0 to 3. Times num sub index. And now how do we get the thing for this one? Index. is map.com combination, no, map.com of, okay. Right minus left plus 1, okay. So that's the n, and then now, but then that's going to be n squared. We do this for every number, right? Is that true? So we have to be smarter about that, because this can be, no, that's not true. Every number can only be on the left or the right once, right? So this is almost like a segment, so it goes like 1 to 2. No, that's not true. Not the way that I did it, I don't think. No, that's 0 and 1. 3 is 1, and 1 and 4 is 0 and 3, and then now the 2 is this one, right? So what does that mean? Okay, yeah. Still people haven't gotten it yet, huh? Like I'm getting closer. The idea is that okay, so that would be n squared. Okay, but I think we have this sliding window thing. So basically, yeah, this is tough though. Okay, and now if you extend, and now first we add, so this is inclusive, that this is the number we want, but it's not right, or it's too slow. So now exclusive is while is this is in exclusive, then we one, and then we inside we add prefix of L. This is so hard. People get it yet? Someone got it. Nice. I don't think this is right, but or rather, I think this is right-ish, but it's off by 1. Somewhere 9 and 13 is just really wrong though. But let's pretend this is right for a second. Then do we get the math correct? So 5 is the min in one number, so this is going to give me a contribution of 5. Okay. 4 is from maybe even the example tells me 4 has 16 plus 36 plus 40 plus 60. So that's actually 152 or something like that. And then the 6 is 36 plus, no, 36 and that's it. So no, not even 36. It's just 6, right? Oh, oh no, it's 36. I'm just really bad at math. Okay, so 25 is the other one. And then now it's 213 from that. Okay. Do I even close to having it? Let's see, inside. So inside 0, no. Am I doing this right? Oh, it should be inside times num sub index. So maybe that doesn't matter because the inside is 0. Because we should be 1 1. Let's see. So this is L R. I think this is -1. Or I mean, it's kind of right, but I think this is +1 instead. I'll figure this out. I mean, I think we're close, maybe. Yeah, though this is annoying. Does white index go out of bounds? I guess white index could be. White index is 4, so then what does that mean? Oh, it's 3. Yeah. Oh, and then it increments, and that means that this is out of bounds, and then this is out of bounds. Okay. But 4 should be okay, right? Why am I doing this wrong? Let's focus on this one for a second. Why is this wrong? 4 plus 1 is out of bounds. Also, it is 4, but I mean, this is it, maybe. Okay, this is just weird, but that's okay. 0 0. Okay, this is good, maybe. Inside is 0, which is wrong, because we want this to hit, and this is 1. I think we do this, but then the left, what does that mean? Left index is 0 all the way, so this isn't even 1 for the first 2. Okay, so this is 5 and 5, so that's good. 29 times 4 is 29 times 4, right? 116 is not right. So inside, okay, let's at least focus on this one. 0 2 3 0 1 2 0 1. Yep, okay, but the 1 is exclusive, so 3 is right then. It's exclusive. And then now we have, I'm too slow on this one. I really should have this already, to be honest. What am I debugging? Why is this only 29? So inside is 5, and then we add the 4. What does adding the 4 mean? That means that we add, so then this is 5 plus 9, right? Okay, and now we add the 6. Oh, I see. So I'm wrong here in how to do it this way. This 15, and then that's 14, 29. The 29 is right, but I don't do the problem is now I don't do the math correctly, because now I'm missing 4, 6, and that's another 10. Okay, how do I do error? Wow, that is, yeah, I'm not surprised a lot of people got this. This is doable, just I'm really bad at this contribution math, I suppose. Okay, so basically, I mean, we have to index these right. My calculation on it is wrong though. So basically what we want to do is get the sum of all contributions between two things, and doing it in a pretty good way. Okay, maybe the way that I was thinking that this would work, but clearly maybe not, because it's missing. When you add a new number, when I add a new number, I'm not doing it right. That's why. Because instead of just adding 9, well, I mean, that gets it to the sum, but not the sum of the sum. So that means that we have 14, adding the 6, we should add 10 plus 15, which is 25, right? 10 plus 15, which is 25, which we don't do. This is 9 right now. 9, and then we plus 25. Well, it's not just 9, it's 5 plus 9, and then plus 25. Which is 39. Another way of saying this: 5, 4, 6, 1, 2, 1, 8, 6, 5. That's it. That's already wrong. Maybe I thought that would be the formula actually, but I was wrong. Should have gotten this one faster though, or should get this one at all. Maybe I don't get it. Okay, so this is 10, this is 15, so this is... I need to do that for every number. Seems pretty hard though. Is it? I thought the prefix sum could handle it, but maybe not. That's 10, that's 5, so that's 15. But now we want this to be 10 plus 6 is 5 is 15, 25, right? Almost want like a second dimensional thing. I thought this would be okay, but I don't know this one. Maybe. I mean, I got the numbers right. I can't figure out the contribution for the sum for these things. And that part is really hard for me. Let's see. Okay, let's actually test something really. Well, no, your form is just wrong, Larry. Can I solve it that way? Maybe my math is wrong. Maybe it's not n squared. But okay, let's see. Okay. Let's see. We have. Right. And this is all left. Okay, this is left contribution. So then if we do 0, yeah, that's going to be n squared if we're not careful about it. If we just do for loop on each, then it will be an n squared thing and we can't redo it. What do I do? And people know how to do it. I don't. I thought I did. I mean, I got mostly right, but maybe. It means that for each number, we count the number from the left and the number to the right. Okay. So, okay, let's think about this a little bit. Slow down, Larry. Maybe you're trying to do too fast. Okay, so this is kind of right. So here, let's see, right? How do I do this in a fast time? I guess that's the question. Because basically it's just each number times left contribution and right contribution. Given these indexes, right? So you could do an n squared pretty straightforward. My math is so weak. That's what I was thinking, right? So each. That's kind of where I got this inside thing from, but my math is wrong. I thought I had an idea. Can I figure that out by the way? No, because each number can be in n segments. Wow, I'm just like yikes on this one. Because basically the formula is pretty okay as well. Just left and right, but can I do that incrementally? And each number on the left adds a new number, right? That's what we're trying to do. And then this number. Okay, let's try this inside wing again. Okay. So we do it incrementally. When you add a new number, what does that mean? You add a new number to the right. It means that there's n contribution of that number, so that's 3 times 6. Okay, so like let's say we do have 5, 4, 6. We have 5, and then now 4. 4 has 2 contributions, so we have 8. So then now we add 13 and no, 4 has 2 contributions. 5 has well, 5 technically has 1, but then now it has to add 1 more for the 4, so 4 has 2, so then 12 maybe. So 4 has 2, and now 5 also has 2. So now, is that right? That's 5, 9, 4, 13, 18, right? And then now we have, okay. So then now from 5 to adding 4, we should go to 18. Okay? And then now 16, adding 6. Adding 6, each of those previous 18. No, that can't be all 18. But 6 has 3 contributions. But get to 41. So you have 6, and then you have 10, 15. So you can't just. I feel like I'm close, but I'm not really. Okay. 6 has 3 contributions. Okay. That makes sense. And then now, but the 4 now, which we said had 2, but now has 3 contributions. And the 5, which we said had. No, the 4 already had, let's see. The 4 already had 2 contributions, so it's 8 and 10 for 18. And now the 4 has 3 contributions, so then. Is that true? Yeah, 4 has. Is that true? What did I say it was? 4 has 1, 2, 3, 4 contributions. Okay, that's what I was thinking. That's where I messed up. I said 3. 5 has 3. This is 1, 2, 3, so 15. 4 has 4, so that's 16. And then 18 for 3. So that's 33, 4, 49. Was that supposed to be 49? Did I mess it up already? Can I just not do math? 49 times 4 is 196. What did I have before? Yeah, my math is really off. Slow down. Let's do it. 4. Okay. So we have to do 5, 4, 6. What does that even mean? 5, 4, 6 means that 4 has to be inside, right? So 5. I think I may confuse it. So that means that the conjugate. That means that 5, 4, 4, 4, 6, 5, 4, 6. Right? Is that right? Yep. Okay. That means it's 9 plus 4 plus 10 plus 14, which is equal to 37. Right? Yeah. What was it again? Contribution of 6. 2 contributions, 4 contributions, and 5 has 2 contributions. Right, so that's good, maybe. So that's why my math is wrong, because I tried it when I add 5 and 4. Okay, so let's say I have. I don't know how to do it. Not quite in an incremental way, anyway. A lot of people are getting it now, though. It's very mathy. I mean, I got most of the idea quickly, but I just don't know how to do this last part. If I'm missing something obvious. So this math seems to be wrong because it only adds up to 38, and that's my math is wrong. Oh yeah, no, my earlier math is wrong. Whoops, I added incorrectly. Okay, so that's fine. I get 38 from this, so let's say I have 5. Contribution is 5. Okay. Okay, let's say 5 and 4. What happens? Well, that should only be 13, really. Yeah. So then what happens when you add the 6? Because this is 4 times 2 plus 5, right? And then now when we add the 6, I think the problem is the way I'm doing is a little weird, maybe. How do I express this sum in terms of the other ones? I think that's the tricky part for me. Maybe I special case same answers? No. I think that's the hard part. The thing is, the thing I need to handle is if it has multiple of the same smallest number. Maybe I can handle that differently versus the generic solution. Maybe I'm just doing it too silly. Because then in that case, it becomes slightly easier to handle, maybe. Because the problem is that I can't even do prefix sum in quite that way. Because for every smallest min, that is the constraint that I'm dealing with. because that's the degenerate case. Otherwise, it'll be effectively linear. Each of those numbers, you count the number of ways you can go to the left. But that doesn't solve what I'm trying to do here. Enough, anyway. I think I need another formula, probably. Because this is what degenerates it to n square. How do I handle that case? I think that's only a case that is n square, multiple mins. Can I handle that incrementally? Maybe I just don't have it. I added another big number. Is it the only case though? I'm not even sure that's true, to be honest. Because now here, okay. So then now we have the answer for the prefix, and then let's say we add a number 7. Right? And what happens? Well, you have these two, so 4, 6, 5, 4, 6, 7. So 7 has 2 contribution. So basically, each number to the right has that's not true. Hang on. So each number to the left of this number Why is it 4? Because that's 2 on the left. 1 or 0. So 2 choices to the left and then 2 choices to the right. And here it just has 2. Maybe I'm not going to be able to get it. A lot of people gotten it. If I have this as magical, then I could get it, but it's not actually, this isn't quite right. You need to know which one's in the middle as well. That's actually one of the problem with this. I thought I didn't need it, but yeah, you cannot abstract it that way. You definitely need the middle. And how do you figure out the math? I do as part of the stack. Maybe I need to do it as part of the stack. I've been kind of abstracting from it too long. Okay. Maybe, I don't know. Okay, let's think. Right, let's say 1. There you go. Okay, we don't need all this stuff. So what does the 3 mean, right? The 3 just... Well, maybe I just know how to solve this one. Because I don't really quite get the thing for it. Okay, so then you have contribution of 2, 4, 2, and then when you add another one, it'll be 2, 4, 6, 3, which is just cray, unless I'm just also wrong on math. Basically, you add a 1, 2, 2 by having, so each of these what are the numbers to the, what happens when we add an 8? What are the numbers to the right of the 4 gets multiplied by 2? How do I do this from a stack? Okay, think now. How can I do this without this degeneracy? If they're all unique numbers, I think we actually have the answer, to be honest. But because of the non-unique numbers, you have to suffer. My mind just keeps dropping even though I finished so quickly on the first 3. But I don't even know how to do this incrementally. The math is tricky. Alright, so we have, okay. Let's try to think about it another way. Let's say we already have the answer right for this. So we have 5, 4, 6. And let's say we have another 4, which only. So we now chop it off here. So the way that we do it, we chop it off the other way. So it's not just the sum of all the things in this span. It's the sum and the middle number. But we need to figure a way such that we can't without. Okay. That means that for each number, that's still n squared. I can't really figure it out. Is there a way to pre-calculate this? Is there a way I can reuse results? That's the part that I'm struggling. Can I reuse previous things? Do some amortization things? Yeah, this is just wrong, I think. Even though I thought I could do something like this. I mean, that's still what I'm trying to do, but this form is definitely just wrong. Basically, from here to index. Let's do a brute force and see if we can figure out a pattern, maybe. Okay, so for this one, how many freedoms to the left? So this should just be nums I times what's left of this. So I minus left index here. These are exclusive, so I need to be +1. And then is this times, wait, for the number of degree of freedom, okay. Times left times right, probably, and then for index plus 1, right. Let's see if this is right. It should be right though. Okay, that wasn't the. I mean, it may be right, but we didn't. I don't know. We're not checking the right thing. 3649 as well. So at least that's something. I don't know if that's a good thing, but that's something. Oh, I think we have to do this times nums of index. That's probably why. Okay, so now this is right. So at least we know that our stuff is right. We just don't. It just doesn't work. Or it's not fast enough, right? Because we can easily just do something like let's see. Wait, it's getting slow, so yeah, that's gonna be too slow, as you can see, because this is n square. Okay, I was hoping to YOLO it a little bit, but people really know how to get this one. I don't know. So this math is right. Can I somehow figure out how to do this thing, right? So num sub I, for example. Okay, so I'm glad that we have some right answers, even though like I wasn't sure about it. So then now you have all these components. Actually, maybe I'm even wrong about the min part. I think it just makes it like if you have slightly less min, you could still have it go all the way, and it still could be n squared. So I think I'm wrong on that one. But with each component, each number can be part of n segments, maybe even more. Maybe we have like a increasing sequence or something like that. Yeah, I guess if we do increasing sequences, it's still n squared, which is not great. I don't know, do it. That does nothing. Focus. I don't think this amortizes, so Hmm. 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 Yeah, I don't think I'm gonna get it, but we have 22 minutes. I mean, I grind a lot on this one. I don't know that. I feel like I'm missing some observation properly. Because I think I'm just trying to optimize this to be linear. Pretty much for the last hour, because I knew how to do it immediately, or I knew how to do the other part immediately. I don't know. I never know how to figure out the contributions. Does it matter? Like, hmm. Hmm. I'm just drawing a lot of conspiracy theory diagrams on my thing. A lot of smart people seem to be able to get it. I'm happy for them. Huh. Wow, a lot of people from China. Actually, don't know what that means. But is there a way to? Maybe I have to look at it backwards. I just don't know how to do it. I don't know how to look at it backwards. I mean, because basically, I'm just thinking, if like each number, is there a way to figure out the total contributions from just this way, like working it really, really backwards, instead of doing it the way that I did with the components, which clearly is not quite working. Like, am I able to use prefix in this? I don't think so, to be honest. Well, like, I just don't know how. Not that I don't think so, per se. Or it's not in a constant speed kind of thing. Okay, wait. Maybe I do have an idea. No, I'm thinking of like maybe doing some segment thing, like a prefix segment thing, but I don't know. Because this is a little bit different because you have to get the right component. So everything to the left, we can, it appears right times plus, this I part is a little bit hard. Because you can say that everything to the left is just, come on. Almost like a sliding window collector later kind of thing. But I don't know that it's quite right. Or like you can, I don't know how to do it linearly. The right part I know how to do it, but then now it's about this part. I mean, this part we can pre-collect it, right? This part not so sure. And then you have to add it to this, but that's fine. We can take out the math here because this is just this times all this, right? But then it's this variable part is the one that I can take out because then otherwise you can do some kind of crazy suffix sum thing, a sliding window or whatever events type thing. I think I have an idea, but I think like this is really complicated the way that I've maybe, so I don't know that this is right. Okay, let's play around with it. I don't know that this is right, so maybe this is not right, and this is gonna take a while. I don't think this is a good, fun idea, but also at 15 minutes, I don't know if I have time for it. But I minus left index because that's number of things. Okay, so then we want to keep track of the left indexes. I have an idea, but it's tough to implement. Oh my. Okay, that means that from left index plus 1. we want to add this contribution here. Okay. That's basically this part. Right. Almost like a sliding contribution collection thing. And here is all the left indexes. Right. Are these exclusive or inclusive? These are inclusive. Okay, so no, that does, well, yes, they are inclusive, so it should be the next one. Yeah, and this is okay. Okay, I mean that is some contribution, and now to figure out the other contribution. Right. Let's see if we still get the right answer. Right. Nope. My math may be wrong. Hehehe. Is that right? No, this should be right. This part, I mean. Inclusive. Okay. Should be right. Seems pretty weird though. I mean, I think this idea could work out, but I'm just really weak about it. And the left indexes. Right. You have to keep track of. There's a lot of indexes to keep track of, and I think you can do it with sliding window and then popping things off. But thought this would work though, at least as a start. I still don't know how to do this part, but I think this is an idea that should work. I mean, I know how to do it, but it's just very hard to get right, and I'm not even getting the easy part right. Index. Is that the contribution? I think that's right. Right, so 3, so 1. One should have contribution from all right. So it should from 0 to 1, right? Okay. 0 and 2 for 3. If I messed up the math, no, that should be right. How did I even get 5 here on the delta? Oops. How do you even get 5 here? Left. That should be right because it's left plus right, right? Let's look at this one. Contribution is 18, -2, 4. Okay, that's just not quite right. Okay. For example, for 5 it's 0, 0. So then these things should just cancel out, right? All right, let's just do one basic one. The delta is just weird on this one, so I think we're clearly having something wrong. It's off by 1 somewhere. That's fine. Left index is 0, inclusive, and then this is 1. Okay, that makes sense actually. And then the left. Oh, maybe that actually makes sense. Except I'm double counting on the insects. Left is 1, so then we do 1 twice on the middle. Okay, so I think I just messed up on the counting on the thing. I think we can just exclude it and that should be okay. Okay, so that's the contribution of the middle. I think I was trying to be too clever, maybe, and I think that just messes things up. Still wrong, but at least it's right for this one. 83, 403. Contribution is much funkier, maybe. I don't know how to do this one. I think I need 1 hint, and then that would be maybe it. But like I need 1 idea, not a hint per se. 25 should be right, but 2, 4, 3. Am I close? Nope. I mean double contribution somehow, but oh, oops, that's because here I need +1 to minus this. Okay, maybe now this part is right. Still gonna be too slow, but okay, still wrong though, so maybe I'm wrong here. The delta way looks okay at least. So the contribution here is 4. Is that even right? Don't know anymore. 1. Let's see. Because we're only taking half of it. It's very easy to be wrong about this. And I'm about to figure out how to do this thing with using like a stack or something. I have ideas, and I feel like if I was better and practiced, I could grind this out, but not today because we have 3 minutes. That's fun, an opportunity to learn something new. So 0 to 1. Yep, that's right. Times index. Yep, that's right. With nums of I. Okay. I think we don't have this part. Are we under? Should be under, right? 213. I don't know if this is right. I guess because the min is the smallest number. But otherwise we're missing some contributions from here. And it's possible that how am I missing a 5 contribution on number 1? Which one am I missing to get 38? I'm missing 6. So maybe it's this one. Oops. Am I doing this right? Index plus 1, we will start. I mean, we can do a lot of crazy maths to keep track. I think I can do it. I'm trying to debate whether I should. I mean, we have 2 minutes. I think I have an idea to be able to do it, but it's way tricky. I think I got it, but I have to get this part first. I think for me to actually be convinced. And I don't even know if this is just luck or whatever. Probably a little bit of luck, because these contribution is 0. Actually, I think that's why. Yeah, that's true. So I think that's why, but for part 1, that's not necessarily true. I mean, I like to keep this. I think okay, I'm gonna see if I can solve this after the time limit, and because I feel like I'm very close and I actually know how to. I mean, I'm getting all wrong answers, but I think I'm getting wrong. No, I'm overcounting, not undercounting. I think that part is a little bit confusing. Oh, because right can be 0. That's why. So maybe I cannot do it quite that way. I'm thinking of, okay, so I think now I get why my things is wrong. So this is this is whatever. All right, now time is over, but okay. Oh, well, this is because this is currently wrong because I had to do something like this. Oh, actually, I guess I think this is right? Still, all right. So this is the right answer that we have. I think the reason why. Oh, I see. I cannot just get rid of. Let's see, right? How do I do math? Okay. It's because you cannot fundamentally separate this part out of the other parts. But I can add a event. I think, okay. I think the delta thing was a fun idea, but I think what I needed to do was add an event. Yeah. And then now we want to start at left index +1, and it has right contribution. Okay. And then we just have, it's just a lot of bookkeeping, but so we want to do this, and it goes from left all the way to index, right? And then we want to add another event that is, let's go this left event just to kind of separate them out. I mean, I think there's a easier way, to be clear, but I don't know how to do it, so this is my way of doing it. Yeah, and I'm you know, just trying my best. -1, but it starts at index, and then left is the component, right? And now we have these things. Maybe I could get rid of this delta for a second. Maybe I could get rid of this stuff. I think this one was maybe a fun time, but not useful anymore. Let's run the code real quick. Oh yeah, of course. And then now, I have to, maybe I have to do something like +1. So basically, okay, something like that. So now we basically converted this into I have to think about it. Is this even right? I minus left. Then as you go from left to right, you get 1 per segment. Right. Yeah. And I have to do some others. I have to keep a lot of things on here actually. I have to keep track of this as well. So then here it goes from index. I guess this technically doesn't really matter, but or this part. They say as you go from left to right. Okay, let's focus on the left first, and then we'll see. Right. I think this is doable this way, but like I said, it's not an easy thing to do. And also, I need to collapse some of this stuff that happens on the same index. Yeah, okay. So what I actually want is yeah, okay, that makes sense actually. You want an array of lists, but that's fine, I think. And then now we do something like yeah. Oops. oops, nope, you want index, and then you append 1 nums of index, right? Maybe, don't know if this is quite right. And then now, and for D, I'm gonna see right in the defense. What you want to do is, okay, now we add a segment. So this overlap maybe 6 segments, and then contribution, and then the contribution is C times R, right? And then is that right? And then as you go right, what happens? I don't know how to do this. Okay, I mean, I think you can work it out this way, but I think I'm gonna cheat and see if I'm clearly missing something. Oh wow, a lot of people got it. So let's see if we can learn together. I mean, this was a fun contest. I like this problem. I just don't know how to do it. Before I do that, let me see if I can think about it a little bit better. I think this is because as you go from, there's just a lot of keeping track, because as you go from left to right on the left events, you get you increment the impact of that node, right? So yeah, it's like a second order thing. I don't know how to do it. All right, let's see if I can learn. Let's quick. You look at someone's. Okay. Contour stack. I don't even. Is that the? Okay. Let's see if. Let me see. Maybe we can see if there's a easier solution. Okay, party queue. This is better, maybe. Prefix sum, and then. I don't know why they wrote it this way, but a prefix sum on the prefix sum. And then just maths. Yeah, so I was thinking, I don't know. Well, these codes are unreadable, but okay, I think this is closer to mine. So yeah, I guess I did prefix sum, and I thought about writing prefix sum, but let me think about this. Maybe I did am able to do this. If this is what I think it is, then I mean, this is basically what I was trying to do, but I was unable to get this particular part. Let me think about this. Let's see. I mean, I couldn't figure out this math, but basically a prefix sum is equal to the previous sum plus the number. So basically it's the, okay, I mean, it's the second order prefix sum from the beginning, but is it actually? It's not the second order. What is it? But then how do you do the math that way? let's see if there's maybe there are more normal solutions. Oh geez, this is not a normal solution. I mean, the idea isn't hard, but yeah, I guess so. I was trying to do something. I don't know that I know how to. Maybe I was just being too clever, or like I couldn't prove it to my head. So the prefix sum works, or like. I don't know. Huh. Alright, let's see. Still learning, still figuring out. Okay, this one I think is maybe closer to what we want. Yeah, I mean this part of the code is literally not this part, but this part of the code is literally what we wrote. Which one is this? Is it this one? Oh, and I forgot which one I clicked on. Yikes. Let's see. Oh, nope. Trying to find that same code back. Though I think now most of these are similar, but so this is prefix sum. I don't know anything about how this folder works actually, but sorry friends, I'm just trying to figure out and learn it as well. We got some of these parts right, but this wanting something is basically what we're doing with the events. But I feel like yeah, I'm not. I don't know. Today I did not have the capacity to kind of combine them. Which one did I click on? I had like one solution that I thought was readable. Is it this one? Sorry friends, hang on. Oh, congrats, doing 9. Nice. Okay. Which one did I click on? There was one that was. Wow, this is way short. Maybe there was just some math that I didn't know how to do. I thought I did, but I mean, this was the part, right? Where I thought I was trying to do second order prefix sum and it didn't work, but maybe I was wrong on that one. To be honest. Alright, let's see. Maybe I couldn't prove to myself in my head and I was just wrong. Alright, let's see if I can do it that way. Real quick. Let's remove this stuff. Let's keep the folder versions. So I can kind of remind myself what it used to be like. Maybe that's why people are able to get it though. I thought I had it, but excuse me. Did I just do the math wrong, maybe? Let me take a look. Okay. I mean, the 29 stuff, I think I knew. yeah, I mean 29 stuff I will, but it should be 38, right? Maybe I'm confusing something. And then now we use it. How do I use it? Maybe I just don't know the math. My math is sketch. Let's see. So what did people say this? I mean, we already. I mean, I mean, we have the left index and then the right index, or is that just what is R? What is this stuff? Man, maybe I should just the more simple one. I mean, I guess the prefix. I mean, I knew that I had to do. I thought about doing the second order one, but I just couldn't figure out how the math worked. Maybe I'm just in. This one we had a good one, right? Oh no, it's this one. Okay, which one is it? Fat fan. Okay, so we have basically here. We have all this code. We just didn't get this part. Let's see if we can work that out, right? So the right sum is just equal to left times what I call prefix of right. I don't know if they do. Okay, actually, I guess they actually use the same notations I did. Minus prefix of I minus 1. Why is it I minus 1? Oh, because it's I and then you're minus 1. Okay. And in this case, we don't do this anymore. Maybe I just was bad at math. Left and I'm trying to do this part without cheating now. Should be able to do it, right? So we want to count from this should be left index is for example left index should be -1, so this is this part +1 and then maybe I'm off by 1 here actually, because yeah, it should be okay. Maybe. Is that right? No, maybe. I know. Still I minus 1 though. Maybe not. Okay. So this is clearly not right. How do you even get this big number? Well, I think this is maybe weird. Okay, so that's not right. So the right total is just this. I think we have to add 1 on both sides, but okay. This is still not right. I mean, okay, this isn't right either. Am I missing some components? I thought I was, because I don't know where they get the. It just got cut off. That's why I was wondering about that actually. I was like, how do they factor that in? Okay, I'm just now copy and pasting code that I don't really understand. But we can dissect this afterwards. But for now, okay. So we got this part, and here it seems like maybe just off by 1. Because this one how do they take account the original number? I mean, this does take account it. We just don't know if it double counts it, right? Yeah, we can take this out, I think. Then now we can see the math. Okay, for the one country. Oh yeah, let's look at this one. This is the one that I care about. How is this just so long? Because basically our contribution should be 38 and it get 58. Am I just off by one somewhere? So the left contribution. And let's double check this. No, that's right. And this is maybe I do have an off by one then. I did actually think about, well, okay, I think there's this part, that's probably why. Maybe I just did have an off by one. This is closer, but maybe now we have to do, because now this shifts by one more. I'm very tired. Okay. Do we get? Nope, we didn't get this one right either. Let's see. How do I get 38 contribution instead of 10? Maybe I don't do this one. Alright. Let me just cheat a little bit more. I'm really tired. What did I do? But this is what I have, right? Why is this not right? I minus. Yeah, I mean, this other thing is exactly what we have, and now we're just copy and pasting, and I'm still not getting it right. That's basically what this part is, right? No, this is this minus one, though. This is. Do they do it inclusively? I think they did it inclusively. And also maybe the left and right could be wrong, but well, not wrong, just different. Obviously, they have the better answer. And then in that case, if that's the case, maybe we. Yeah, maybe I do this. And in this. Okay, let's see what. Yeah, and then now. Well, we do +1 -1, so, but left index can be negative, right? So that's not gonna fly. That doesn't even make sense. But +1. I think we have like very subtle things that are different. That's why, with respect to the indexes of the things, we can probably maybe debug that, but maybe not. Maybe they're doing it a different way. Actually, I thought we were writing the same code, but our stack is actually maybe slightly different. Because I think theirs is inclusive. That's why we're minus exclusive. So because mine just returns to the next one. Alright. No. That means that this +1 will be 0, and then we have to do another. I don't know anymore, friends. I'm just so tired. I think this is more right, but this is clearly still not right though. It's still off by a little bit, clearly. Unless this is this +1 on the prefix. Nope. I mean, unless I'm just off by 1 by it, because I'm doing a prefix of the prefix of the prefix, but am I doing this wrong? Why do they have an extra thingy? Maybe that's it. This is just like really weird too, because I think this is technically just wrong, or like this goes out of bounds, but it's just that the -1, it just returns the right one because it's 0. So I think there's just like some weird wrong answer here, or not wrong answer, but imprecise answer. Say it's clearly still better than mine. But it also means that I don't know. Maybe I think that's what I wanted to see. And then now here we don't have this other thing. My left index is weird. Oh man. Like I had this, that's why I couldn't put. So one thing I would say now is that I'm not able to debug it because I don't really know how this works, and that's part of it, right? Is that if you don't know how it works, of course it's hard to debug. So I was hoping to kind of do it backwards, to be frank, which is to kind of figure that out and then like get the code correct and then figure out like playing around the property. It seems like it is mostly correct. It's just that I don't know how to, like I'm having struggling with some off by ones. But let's maybe we can figure it out together then. It is what it is. Okay. Right, so now we have all this stuff. Let's focus on this one. How do I get to 38 from here though? From the 4. Right, that's the part. Am I missing a prefix something? Alright. Let's actually also, I mean I was trying to do it in a whatever way, but let's actually see, you know. This is a very hard problem, of course, in case you haven't. Oh, this isn't Python. That's good. Okay. Because then now I can at least like kind of see. Maybe maybe my my assumptions are not right. Oh, is this not? Oh. Because this is closest to what I think is good, or what I do, but Yeah, I mean, okay. So actually the left and right is same as mine, right? I'll print that out here. So what am I doing well? Right? Hmm. Oh, I called it left and right, but this should be left indexes, right indexes. Yeah, okay. So actually we match on this part, right? And then we match on everything. They have extra zeros because actually they don't. Like I said, I think they made a little bit of a off by one here, or maybe I mean, this is during contest, right? So I don't, I'm not trying to crap on them. If it sounds that way, my apologies. But that's why there's this discrepancy. Okay. So then now, okay, let's. Then what is the difference here, right? Why is this wrong then? So then now I just add one to all this stuff. It is what it is. So let's you know let's point out the left sum, right sum, a sub I, right? I guess we have it kind of here. So, but we don't have a left sum, right sum contribution type thing. So let's do that. There's actually multiplied by a sub I, so we can maybe do that here as well. In case you're wondering, though, sometimes I get questions about what happens when you see a problem and you don't understand it and you look at code, right? For me, this is what I do: is that I dissect it in the ways that I can do as possible, and then figure it out. I think I don't get how this even works. Right? Let's see. Like, isn't that just our bounds, or is he just like really lucky with it? I mean, it could be just that comes out to be. Like, yeah, left sub I minus. This is just like very lucky or something, right? I don't know. I mean, if it's intentional, I apologize. That's why I'm like, if I do -1, would that work? Is that how like nuts this is? In this case, it would actually just be this because I have an extra 0. But yeah, I don't get it. Okay, but in here, in either case, left sum is 0 and right sum is 0. Maybe the reason is because this I is this is way because he does a lot of things that cancels out in a really weird way. Because this is 0 and this is 0, so this is why the left sum is 0. Okay, fine, right? I think I might have done. Yeah, I did the left sum and the right sum incorrectly, so but that's fine. So 0 and 5, right? Is how they did it. For me, 0 is 5 as well. So the subtotal is -29. So, oh wait, no, that's because we fixed some of this, or we changed some of this stuff without. Yeah, okay. So this is contribution would be 5. Okay, fine, right? And then here contribution is 12 from the 3. That also seems reasonable. Yeah, and I think I get that here as well. And the next is 36, but I have 46. Oh no, this is 10 and 36, so is that same? And then 14 and 0, and then 14 and 10. Okay, so this is where we differ on the 2. Right? This is how I get, wow, what the... let's also just do this like for a straight comparison. I mean, I feel like we mostly had the idea, but I think we're clearly struggling with some off by ones, right? Oh, I see. Where I add them, she subtracts, or he or she subtracts them. Maybe I am misunderstood ending this problem. Just okay. I mean, I think I clearly do not know how this works. We can work out the math though. I think it is. I mean, it is mathematical. Nope. This is the one with the left is the right sum. So okay. So that's why the off by ones. I mean, or at least I have issues with. I mean, there's still one more. You know, I have the 10 here, which is the left sum. Again, there is some crazy out of bounds type situation here. So this is no. I mean, this is not out of bounds, but it's still a little bit off. Huh. How did I get? So the left. So we're doing the left sum. Left sum remains 10 because this is 4. So why is it different? Why is it getting 0? What is that again? So that is left sum, right sum. So this part is 0, right? So why is this part 0? Why is this part 10? Right? Do I have a typo? There's a lot of stuff that's potentially off by 1, to be honest, so wouldn't be that surprised. But especially this part where there's a -1 because I don't know, what if it's just wrong? Would just being abuse the -1 save it? Nope. Okay, so I cannot get away with this, and it shouldn't be, but so left and indexes of this. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 2, right? So yeah, left index is 2. So it goes to plus 1 is 3. So this is 10. So this minus, so this part is 10 instead of instead of 5. Is that right? Wow, I'm like really bad about this. Okay. Okay. Let's just print it out, right? So we think that this should be thingy. I'm like really bad at visualizing right now, but that's okay. We're learning together, hopefully. Okay, so this is 10 and 5. Okay. While for us, we get. This is why you know having a debugger is helpful, but we're doing it funky together. 10 and 5. What? Dum dum. Dum. The pot frickens. Wait, what? Did I do it wrong? Oh no, this is because I have to add 1. Okay, so that's why we're wrong. Okay. 10 and 10. Because we're trying to be inclusive. The way that they did it is so funky that I think like they just have. I think there's a lot of luck in how this one get accepted, but nonetheless, I think that's why I'm having struggle replicating it. I think the right way to do this would be something like this, maybe. And then now, maybe not actually, but because the left index of this one, what is the left index on this one? Let me double check. 5th character, so 1, 2, 3, 4, 5 is 2, and 0, 1, 2. So then this plus 1 is itself, right? But that doesn't make sense. No, so this should be, let's see, should be 10 minus 5 from what they suggest. Sorry, friends, I'm taking a long time. And yeah, okay. Why is that? Oh, so that you could get itself. It should never equal to itself because of this. This plus 1 is mixing things up, kind of. I think everything should be plus 1. Well, now that we moved it, I think everything should be plus 1, and maybe that's a little bit better. Well, okay, we don't need to do it here, but I mean the original sin is just that they really got the indexes really wrong in a lot of places in the solution that I looked at. But okay, so yeah, now that I fixed that, it should be okay. Okay, let's give it a quick submit, and then we'll go over explaining it. Well, we'll do the explanation in the. Well, okay, we are gonna do the explanation in the video, but thank you. Give some props to who was it? Fed fan for this. So I think yeah, now we can figure out how this solution works, right? I think it's just a lot of math, and this part of the math I actually don't know how to do. Let's see. Wait. Excuse me. I mean, I think this is just me not knowing the math. I'm not gonna lie. Maybe a little bit out of practice, but I don't know if I knew how to do this one. Let's see if there are other ways to kind of do it without it really quickly. I mean, no, it just seems like mostly the same way. I think I just don't know how to do this. I don't know the math behind this one off my head. So let's discover it together, right? So basically, Right. Okay, we don't need this per se. I mean, I think for me, it's just about understanding the prefix sum of prefix sum. And then here, I mean, this part, understanding it is not that bad, but it's about the math of how to calculate this, right? Yeah. I mean it. I mean, yeah. This I just didn't know the math for this one. Okay, let's see if I can figure it out. Let's see. Right. So let's say we have 5, 4, 6, and then this leads to this thing, right? Let's see if we can learn something here. What does this mean, right? So the prefix sum means that this value is, well, just 0. The next one is going to be 5. The other is 5 plus 4. The second one is going to be 5 plus 4 plus 6, right? Oh, yeah. And then here, what is the prefix sum of the prefix sum mean, right? So 0 is going to be just 0 plus 0, I guess, but I'm just going to write 0. 5 is going to be 5, and then 14 is going to be 5 plus 4, and then the 29 is just 5 plus 5 plus 4 plus 6, right? Oops, I missed something. So that's what that means, right? And the part that we're trying to excuse me, I mean, this part I actually had some, I was thinking about when I was trying to count the contribution, I was trying to figure out how to do it in that way. In that, let's say you have let's say you have I'm just trying to think. Let's say, right, like, how does this work, right? So how does this formula work? So let's say we are at the 4. So we already have the 5 by itself, so we have, 5 times 5, 6 times 6, right, by itself. And then now we have to figure out the 4 contribution, right? So then now for 4 contribution, and this is what I wrote in my paper, is that we have 5, 5, 4, 5, 4, 6, and then 4, 6, right? Those are the contribution of, oh, sorry, not 5. So what I meant is, so you have 4, 5, 4, 5, 4, 6, and 4, 6 in some order, right? So those are the contributions, right? So then now, how does this formula work, right? So the prefix, so this is just, and of course, keeping in mind this part, but that's okay. That's just a contribution, right? So then now what this is saying is, actually, maybe another way that we can think about it is using ones, but maybe that's a little bit confusing, maybe. Okay, let's stick with this for now. So then the left sum, the contribution of, so this is actually the right sum. So let's do that. Right. So the total prefix sum, right sum. So the total prefix sum is equal to the number of numbers on the. I don't know what this means. I think that's like in a non-mathematical way. Right? So okay, let's break that down. Okay, so we have this for loop, and we have these 2 for loops. That's equal to these 2, right? So that's basically what we spend an hour on, or these 3 for loops, including the this. Okay. Whew. So basically, the idea behind prefix sum in general is that you have this segment, right? So let's call this the right contribution, weight contribution maybe. So we have some prefix sum that's weight contribution, which is equal to let's actually break it down. Let's pretend that the nums of index is 1 for now, so we can just ignore it. Like we like the interesting part. I mean, it's not like this is the min part, right? And this is the sum of the components part, and we're trying to figure out how to get this part first. So we'll ignore this for now. And I'm just talking to myself, honestly. But and I'm talking to myself in that what is this formula saying, right? So this number is the inclusive of the right index. So the 4, it's going to be everything, right? So it's going to be this number, right? This number minus this number, which is the stuff that is, because we want to include the index, but there's 2 off by, or 2 plus 1s, which is why this is a little bit weird. But it's this minus the thing that includes it, or not includes it, is kind of confusing. But yeah, I think this is just 5 for this part. I think, wait, where did it go? Did I mess this up? Oh no, I added a comma, that's why it's confusing. But this is this 5, right? Oh no, this includes the index, so actually it's this number, 5 plus 5 plus 4, right? And then so what does this do? This gets the prefix sum of right index to index inclusively, or does not include the index actually, right? So here, and you can see that here, that just means this is equal to 5 plus 4 plus 6, right? And what does that mean here in terms of how we do it? And also, because I am confusing as hell, let's actually print this out so that I don't I'm not checking the wrong thing. So this is just let's actually focus on the 5, 4, 6 for now. And this is me teaching myself, just to be clear. So if it doesn't make a lot of sense, I apologize. I mean, the video will be a little bit better. So I was wrong on this one. Right indexes, yeah, okay. Did I print out the wrong thing? How did I? Oh no, that's because this is the 5 component, this is the 6 component, and this is the 4 component. This is what we're looking at. So 29 and 5, right? So this is okay. So I was wrong on here. So it does include itself. This is off by 1 and off by 2. This because it's okay. I see. Because in a non thing it'll be -1, but you add 1, but then you add another 1 for the other one. So yeah, okay. So this is this. It's equal to 5 plus 4 plus this other thing, right? And then the left contribution is just the number of flexibilities that you get. Yeah. Right. I mean, that part makes sense. So this is 24, right? So this is 24 times left, where left is well, just the numbers on the left, right? So this is on the right, so that means that there's one number on the left times 2 for degrees of freedom. So left is equal to 2. So this will give us a contribution of 48, right? Again, assuming that the number is, we'll just ignore the number for now. But, okay. And then the left contribution is a negative contribution, but why? How do we do it? Right, so like we have this thing and we're trying to figure out this, but I still don't quite see why, to be frank. And here is just well, 5 minus 0, which is equal to now 5 times number of things on the right is equal to 10, so that's equal to 10, right? I think that's right, maybe. What is it? Oh, yeah, okay. Let me double check whether I'm right. Hang on. So this is the right contribution and this is the left contribution. Okay, so that is right. And I mean, we'll just skip this part anyway, but why is that right? Right? Because that's all the contributions of 4s, right? Okay. What is the 2 part? Okay, so now we're trying to see if I can figure out deeper meaning here, right? So the 5, like I don't get how this mixes up all the right. The prefix things is way weird. I see it, but now a little bit. But okay, so what is this 48 exactly, right? Well, it's basically 5 plus 4, 5 plus 4 plus 6, right? So that's basically what this is saying, is that yeah, okay, the 2 is just the number of numbers to the left, right? So that's we're not going to go over, or that's the part that we'll go over in an explanation video, but it just shows that whether there's 5 or not, right? So but we want to get the 4, 6 part. So now we times it by 2 because now we have 2 versions of this, say right? And why do we have 2 versions of it? It's because one contains, yeah, okay. And then now the left contribution is basically getting rid of number of right components, right? Meaning things that are counted. Yeah. So we want to get rid of these 5 for sure, but also Is this right? Oh no, I did this wrong. So this part is this, right? So when you get rid of the 5, what does that mean? That means that you're getting rid. This is how prefix sum works, right? So now we're getting rid of this part, right? And then now, so basically, this is this component of this, right? Is the right contribution. So we have this answer. Yeah. Right. And then now the 2 is I know how to kind of figure it out, but I'm still trying to figure out how to visualize it in a consistent way. And yeah, and basically you have, this is the prefix of the prefix sum, and then now there's the 2 component. How do I visualize this, right? So this part we just visualized into the contribution. This is the sum of the sum of the sum, and then 2 because we want the 6 to have 2 contributions, right? The 6 has, everything to the right of the 4 has to have at least 2 contributions each, kind of. Maybe I'm not saying that way, but now we have this, right? And then the idea here is that the left contribution is just minus. So the 5 minus 0, you can think about it as just having these 2 things as the contribution. The 2 is because basically we want to negative these things out. And then the idea here is that you subtract 1 from here, for example, and subtract 1 from here. And that's basically how you get these 4 is this 4 number here. It's basically the idea. Okay, I think I mean this, I don't know. So there are 2 things. Right? One is that, okay, let's say you pretend you believe this. Then the question is then 2 things, right? One is, do I believe myself that I learned enough? And 2 is, can we, like, how does the generalization work, right? So I think that's basically the idea here that I'm trying to figure out. But let's actually now use some more abstract terms, right? Now that we kind of played around with an example, let's say we have this, we have it's hard to write, so I'm just gonna say okay, I'm gonna bring up my paintbrush. I think I was debating that part basically. Man, I was so fast in the first couple. It's a little bit sad actually. Let me find where's the thing. Nope. Okay, there we go. Also, let me turn on the light. Turn off this light, maybe. Okay. Where's my pen? Did I just drop my pen? I had it on me. Like my drawing pen, not my. Where did my drawing pen go? It's like right here. Hang on, friends. Huh? Did I lose it? I just added. That's weird. Oh, there we go. I guess I did drop it on myself. Okay. So now let's say we have okay, so now let's say we have a sub 1, a sub 2, ... right? So then now the prefix sum is going to be just 0, a sub 1, a sub 1 plus a sub 2, a sub 1 plus a sub 2 plus a sub 3, right? And then the prefix sum is 0, maybe another 0, but whatever, right? A plus 1, a plus 1 plus a plus 1 plus a plus 2, yeah, a plus 1 plus a plus 1 plus a plus 2 plus dot dot dot. I'm just gonna dot 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 because I'm running out of space, right? Okay. So let's say I'm just trying to use another general examples to generalize a little bit. Let's say we have 4 numbers, right? So let's say x is equal to 4. Then what does that mean, right? And let's say in this case our left is equal to 1 and our right is equal to 2. That means that, you know, we have, let's say an example is 2, 1, 2, 2, right? So then we go 1 to the left, 2 to the right, right? So that's basically the idea. And then kind of the formula here then, right, is that we're gonna have is just going to be, let's see, right? So we have, I want to say a plus 1 plus a 2 plus, oh, did I mess it up? Yeah, I did mess it up a little bit. Okay. Oops. This is not that much better. I mean, I'm enjoying it and I just running out of space. Right. So that would be the right prefix of these 4 numbers, say, the 4 numbers. And then we subtract this from, do we do the number? The number that's to the left of it, right? So that's just a1. So that means that we subtract the prefix to get the segment from, in this case. Also, let me just clean this out because this 2, 1, 2, 2 is confusing, but I just wanted to give a visualization. But yeah, but basically we just get rid of a1, right? To get the suffix. And then because they're on the left side, we have 1 number. That means that we have 2 degrees of freedom, right? So that means that we write it out, we have this thing times 2, which means that we contains the component a sub 1 plus a sub 2, a sub 1 plus a sub 2 plus a sub 3, and then a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, right? So you have this times 2. I'm just going to see if I can copy and paste it real quick. Can I just move this? Okay, well, maybe not. Okay, I'm just going to write it here and then also copy and paste it here, right? So now we have these things time because we have 2 parts, right? And then now we're trying to basically do the negative version of this by, well, by basically crossing out all the ones that makes it duplicate. Right? Is that right? Yeah. So basically now we're just crossing out, oops, that's not the right drawing. Basically now we're crossing out all these things. So then we now have the complete 6 different answers. Right? So that's basically the idea. though it's really hard to come up with this visually. I mean, I'm not obviously figuring this out backwards a little bit, but yeah. And we know that this is how the formula works. Now I think I have a better understanding of why we get to multiply this by the right, because here you can see that because you can see that if we multiply by the left amount, we duplicate it, we copy and paste it in this way but for each of these, we want to remove the number of right freedom, degree of freedom, right? So that's basically the idea. Okay, I think I get it now. I'm not going to explain a little bit further, only because I'm going to save it for the explanation video. I would say that I understand it now. I don't know that I am at the level where I can, excuse me, I'm not sure that I am at the level where I can come up with this. But yeah, all right, that's all I have for this contest. Let me take this away. How did I end up doing? I don't even really know. 328, which is kind of rough considering I was 9th after the first 3. So that's kind of tough. A lot of people got it, so a lot of people are smart. See how, oh jeez, but what the okay, I mean the left and the right is the same idea. I think I just don't, maybe this is a technique that people study and more, but and I conceptually I feel like I could have maybe eventually gotten it, but it's also just hard. I don't know how this one works. Or like I don't know how this one runs in time. I don't get it. Let me take a look at this one actually real quick. Oops. Because this is basically the idea that I had, maybe. But this is like, is this fast enough? I guess so, but yeah, maybe it's fine. I don't know. I'm too. Okay, that's what I have with this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem's explanation and all that stuff. Stay good, stay healthy, to good mental health. I'll see you later and hopefully next week. Bye bye.